Okay, we'll discuss. கொஞ்சம் கீழே படிச்சுக்கணும். Okay, Bhuta, we'll discuss these questions. May in this part, now Tagalasi answer the questions given below. Normally, this is structured to say the people who are going to face uh, the A-level paper. Like if you have in the paper, this you will get this question as the first structured essay in your exam. Definitely, you will get something like this. Now see this, can you see N3 minus KiO3, Li3 and lithium nitride, BrF5, BeO, K2MnO4, sodium, thiosulfate, these things are given. First one, which one has a square pyramidal shape? What do you mean by square pyramidal? Can you remember square pyramidal shape? How many things should be connected for that square pyramidal? 1, 2, 3, 4, 5. This is only known as square pyramidal. It's got an item which has connected with 5 things. Out of these things, which element is connected with 5? BRF5. What is the answer for that? First one answer is BRF5. The PDF is shared in the free session group. Right, so answer is BRF5. Second one. They have asked the species that reacts with water to give a gas which turns red litmus blue. Red litmus blue with water. Red litmus blue karane ka hota? Base. So who is the basic solution? Which can form a basic solution? Lithium nitride. Very good. How you know that? Lithium nitride is not a base. Actually, this reaction is not there for you. Grade 12 people haven't done. But how do you know it forms NH3? Huh? Huh? What's that? The equation. How do you know that equation? How do you know? This comes under unit 6. But how you know that? Who helped you? Tell the truth. Who helped you? Tell the truth. No one helped? Right? So now lithium nitride and water, where lithium nitride is only correct answer. But actually, grade 12 people, they don't know this. ඒක can't do, right? It can't do. Can't do නම් can't do ඒක. ඒක කරන්න පුළුවන් නම් only one way is there. Right? What is the even writing the reaction lithium nitride will give ammonia කියන එක වෙනකන් if you know එන්න පුළුවන් එක method එකෙන් විතරයි පුතා. Only 26 A level students know this. 27 A level students can't know this. ඒ කියන්නේ they can't ඒක බෑ මේක බෑ. Because we haven't learned this reaction. Lithium nitride plus water reaction. Okay. We don't get that. All right. Okay. Now, okay. May Puta, can you join through YouTube? Without this, I'll send the link you. It is in the free session group, the link. Otherwise, you just click this and you join through the YouTube, Puta. Otherwise, fine. Okay. Okay, shape. No need. You just stay like that. Okay. No, okay, it's fine. Now, say this, Puta. බඩු මාට්ටු කියලා කියන්නේ. Anyhow. Because you haven't learned that. Uh-huh. ඔකත්ද කතාවේ තේරුව? කම්මේ කියන්නේ. ඔකත් දවුල. Now see this. Now, okay. Alright. The species that reacts with water to give a gas, which turns red litmus blue, answer is lithium nitride. The compound which reacts with both sodium hydroxide and HCl. So who can react with sodium hydroxide and HCl? It should be an amphoteric oxide. Hari, that also 27 A level ekata poddak amaruyi thamai. I'm sorry for that. Eka answer එක. Yes, answer is. ඒ කොහොමද මම උඹලා ගන්නේ ඕවා? Y'all very intelligent, ba. Then the third one is what? Beryllium oxide. Beryllium oxide is the amphoteric. Again, remember beryllium, yeah, normally amphoteric oxide, just remember amphoteric mean amphoteric oxides. Remember beryllium, aluminium, you know, aluminium oxide is amphoteric. Likewise, beryllium also amphoteric oxide. Just remember that. At the moment, just remember, will you? Like this. The compound which is used as primary standard in volumetric analysis. Potassium iodide, KiO3. The species which is isoelectronic with N2O, which is isoelectronic with N2O, both on KiO3, which is isoelectronic with N2O. Isoelectronic with N2O mean? What is N2O? N2O mean, first of all, how many electrons are in N2O? You check. 2 nitrogens and 1 oxygen. 2 nitrogen, how many electrons? 1, 7. 7 into 2. How much? 14. For oxygen? Oxygen? 8. 14 and 8? 22 electrons are there. Now you check who has 22 electrons. Which one you got as the answer? N3 minus. Very good. N3 minus only has 22 electrons. Answer is N3 minus. Number 6. Which one can undergo disproportionation in acidic medium? K2 MnO4. K2 MnO4. This is the thing who can undergo disproportionation reaction. We didn't write anything with sodium thiosulfate. Ega sodium thiosulfate also you can write as primary standard. Okay. Now they have given a skeletal structure of CN3 minus ion is given below. But remember, you should be able to draw this properly. Maybe how many things are correct? Out of 6. All correct. Right. Good. 5. How 5 correct? Because there are 7 options. 3 correct. All right. Now let's check. CN3 minus. CN3 minus for this. Okay. This is N. Huh? I shared, right? Deny share the link in WhatsApp. Vandilla? No? ഇല്ല വന്നില്ല ഓ we haven't shared. Guys, this need help. ടക്കന അതിന് എന്താ ലാപ്പിന്റെ ചാർജർ ടക്കന എടുത്താൽ മുന്ന് കടിച്ച് എന്താ ഇതിൽ Okay, now say this. Shh. Observe here, Tatakala will discuss this. But remember, I saw a weakness in this part. Therefore, Chuttak see this properly. Now, under CN3 minus. Now check carbon. Now check, is it there? Check, is it there? Is there? Okay. All right. Now, carbon mean, remember to draw the structures. First of all, see the number of total valency electrons. Carbon for 3 nitrogen, 3 into nitrogen is 1 nitrogen is 3, 3 into 3, 9. With the minus charge, 4 and 9, 13 here, 12. So, number of bonds will be 6. If there are 6 bonds in this, so NC 2N. NC and 2 N's are here. Alright. So you have to connect this like this. I have to fix 6 bonds. 1, 2, 3. Only 3 bonds are here. No, so I can fix 6 bonds. Then I'll put 2 bonds here. Okay. Then 1, 2. Then I'll put 1, 2, 3, 4, 5, 6. Okay, no? If I want, I can put 3 bonds here and I can put 2 bonds here. They have asked the Lewis structure. Most acceptable Lewis structure. What is the most acceptable Lewis structure for this? Again, now I can, if I want, I can draw 3 here. Right? Okay. Now I can write like this for this 2. This carbon is okay. This nitrogen 1, 2, 3, 4, 5. This nitrogen 1, 2, 3, 4, 5, 6. I can put a minus charge on nitrogen because nitrogen is the most eligible person to get a minus charge. So this is the best structure for Lewis, the best Lewis structure for CN3 minus. Remember, Buddha, out of this, most eligible person to have a minus charge is nitrogen. Is it correct? Is this Lewis structure correct? Good. And they have asked draw another 2 resonance structures for it. You have to know 2 more resonance structures for this. If you draw 2 more resonance structures, you cannot change this. Again, structure should be same. Structure should be same like this. But you have to change the resonance structures. Okay. How can you change the resonance structures? You can put a triple bond here. Then you get a plus charge here. Here also you can put another triple bond here. Then if you do like this at 11, bonds are extra. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I can put 2. I can put maximum 2 here. It's 2. Because maximum how many bonds I can put? 1, 2, 3, 4, 5, 6. No, so I can go up to only 6 bonds here. I can draw here nitrogen like this. And for this nitrogen, I can put a plus charge. Normally carbons, valence is 4. But this carbon maximum I can put 3. No, so I have to put a minus charge here. Then for this nitrogen, 1, 2, 2. Then 1, 2, 3, 4, 5, 6 here, I have to put a minus charge like this. So we get an unstable structure for this. This one unstable structure. After that, I can draw like this another structure. Always draw the first skeleton. Again, for this skeleton, I can put total 6 bonds. So I can add 3 more bonds for this again. If I want to add 3 more bonds, what can I do? For everything, put 2, 2, 2. For this 2, for this 2, for this 2. Normally nitrogen valence is 3. No, careful listen. How to put the charges? Nitrogen valence is how much? 3. How many bonds it has make? 2. So what is the charge on nitrogen here? Minus charge. Why? Because nitrogen can make 3, but it has made only 2. This will have a minus charge here. This nitrogen will have a plus charge. 1, 2, 3, 4. This carbon is okay. This nitrogen also will have a minus charge like this. So if there is a minus charge around nitrogen, there should be 6 electrons. There should be 6 electrons. So 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. This nitrogen will have 5 electrons. 5th electron has gone. Can I understand this? So these are the other resonance structures for this. All right. Based on the Lewis dot dash structure below and the numbered skeletal structure beside it, complete the table below it. Now you have to complete the table. All right. Now you have to, if you complete this table, first they have asked you to write C1, C2, N3, N4. Number of VSP, VSER pairs. All right. But how many VSEPR pairs are there? What is VSEPR pairs? Valence shell electron pair repulsion units. What are the valence shell electron pair repulsive units? What are those? The sigma bonds and the lone pairs. Sigma bonds and the lone pairs. So I will draw the structure here. So this is CH3, no, this CH3. After CH3, you get here another carbon. So here you get another oxygen. You get nitrogen. You get double bond nitrogen. You get another double bond nitrogen like this. That is. Then this one is known as C1, C2. They have given N3, N4, N5. This is how they have given the structure here. But they haven't put necessary charges or anything. They haven't put here. So you have to put this. They have put, no? They have put on nitrogen here, you get a plus charge. On nitrogen here, you get a minus charge. Right? This oxygen, you get a minus charge. Sorry, that oxygen double bond oxygen. I'm sorry. You get a double bond oxygen here. For this double bond oxygen, you get like this. Right? And here you have like this. Right. Now, first thing, C1, C2, N3, N4. Number of VSCPR units on C1. Check the C1, how many VSCPR units? 4 sigma bonds. Answer is 4. Answer is 4 for that. For C2, Buddha, tell how many VSCPR units are there? 3. Very good. 3 sigma bonds. Out of these 2 bonds, only 1 is sigma. In this, how many sigma bonds are there? 1, 2, and 1 lone pair. So for N3, VSCPR units is 3. For N4, 1, 2, only 2. VSCPR units are sigma bonds and the lone pairs. Electron pair geometry around the atom. Electron pair geometry means you have to see how many VSEPR units. So this one tetrahedral, this one trigonal planar, this one trigonal planar, this one linear. After that, shape around the atom. This shape also tetrahedral. This shape is trigonal planar. This one, 2 sigma bonds and 1 lone pair. It's angular. Then this one again linear. Shape around the atom also hybridization. Hybridization, you have to check from the VSEPR units. 4 mean sp3. 3 now sp to 1s and 2p's. This one also sp2. 2 now 1s and 1p sp. This is how you have to fill that. Clear? Then the next one. Identify the atomic or the hybrid orbitals involved in the formation of sigma bonds between the following 2 atoms. Sorry. Now, you have to write the atomic orbital or the hybrid orbitals. Hydrogen mean what, Puta? 1s. 1s atomic orbital, this hydrogen. C1 mean? C1 is 4 sigma bonds now. sp3 ne? sp3 now hybrid orbital. So first one is atomic orbital and sp3 hybrid orbital. Between C1 and C2 now, C1 is sp3, C2 is what, Puta? sp2. What is the orbital? Hybrid orbital. This is also hybrid orbital. It has a C2 and N3, no? C2 is here, N3 is here. So C2 is sp2 hybrid orbital. N3 is what? sp2 hybrid orbital. This is also sp2. For the orbitals hybridization, we check the sigma bonds and the lone pairs. Then if you see N3 and N4, here N3 is what? sp2 hybrid orbitals. Here N4 is sp hybrid orbital. You have to see only the sigma bonds and the lone pairs for this hybridization. Then N4 and N5. This is sp, sp2. So sp hybrid orbital and here sp2 hybrid orbital. So this is how you have to write the hybridization, hybrid orbitals or the atomic orbitals of these sigma bondings. Now the fifth one. Identify the atomic orbitals involved in the formation of pi bonds between the following 2 atoms. Now you can see the pi bonds are formed here. Between N3 and N4 they have asked. This is a pi bond. There are N3 and N4 pi bond. You can see N3. N3 means this one, no? N3 is, they have formed sp2 hybrid orbital. Who have involved to make the pi orbital? Other p. Which level? Nitrogen is which energy level? Nitrogen second energy level, second period. No? In nitrogen, which one is involved to make the pi orbital? 1. At 1s and 3p's are there, no bang. sp2 join to make the sigma bond mean this p will join to make what bond? The pi bond. So this p is in which energy level? Speak, Puta, which energy level? Nitrogen is in which period? First or second period? Second period. Pi orbital is made by 2p. Make it 2p. Then N3 is 2p, N4 also will be what? Huh? Okay. So N3 is what? Again, this sp2 is involving to make the sigma bond. One, normally when you take an orbital, 1s orbital and how many p orbitals are there? 3p orbitals are there. When there are 3p orbitals, right? When 1s orbital and 2p orbitals are involved to make the sigma bond mean, this orbital should involve to make what bond? Next orbital only should involve to make the pi bond. Next orbital is what? P. Which energy level? Second energy level. Therefore, 2p hybrid orbital. 2p atomic orbital, I'm sorry. That is not hybridized, no? Only one orbital is there, no? 2p atomic orbital and N4 එකටත් මොකක්ද? N4 එක sp නේ. N4 also 2p atomic orbital. This p also in the 2p. No? Can understand, පුතා? ඒක හරිද? කොල්ලෝ clear? Right? එලගිර. Sorry. Didn't you hand over the papers, කොල්ලෝ? No, you gave the paper. Correct. Many. Now, uncle on the papers ಇಲ್ಲ ಈಗ ತಾನೆ ಸರಿ. Now see this. Now put the N4 and N5. Where is N4? N4 is got N4 also involving what? 2p atomic orbital length, 2p atomic orbital length, other 2p atomic orbital. Everything will be 2p atomic orbital. It was C2 and O6. This pi orbital, what is the hybridization of this sp2? Either this one also 2p, this one also what? 2p, everything 2p. 2p atomic orbital, 2p atomic orbital. Don't have a thing like this. Every time 2p, that one will be the answer. You just check who are involved for hybridization. Then whoever next atom, next orbital will involve to make the pi orbital. Are you guys clear? All right. Mention the approximate value of the bond angle around the following atoms. C1. So the C1, what is the bond angle? C1, what is the bond angle? 109. C2, trigonal plane, what is the bond angle? 120. Trigonal plane can remember these angles. TNM angles, how many angles? To remember 3 angles only. Don't tell, can't remember. If it is straight, if it a linear shape, 180. Trigonal plane, 120. Tetrahedral, 109. Only these 3 things you have. Can't you remember 3 angles? And if you remove 1, then the next one, N3. N3 is what? Angular. How angular came? They have removed which one? They have 1 from trigonal plane. Can understand? If they remove 1 from trigonal plane, it become angular. So trigonal plane is 120. Now angular become how much? 2 degrees will reduce. Again, because of this one, 2 degrees will reduce. Because of 2 electrons, 2 degrees will reduce, and this become 118. Then when method at the end 118 you get the answer. So between N3 and between N4, again around N4, N4 is linear. N4 is linear, that is 180 degrees. These are not big deal. Fine, arrange the following atoms in the increasing order of the electronegativity C1, C2, N3, N4, N5. Puta, who is more electronegative, carbon or nitrogen? Who is more electronegative, carbon or nitrogen? Huh? Nitrogen. Either both the carbons should come least, nitrogen should come highest. So now you have to compare both the carbon. Out of these 2 carbon, which one is more electronegative? Now this one is saying what hybridization? You have to check. Can you remember hybridization, charge, oxidation state, attachment? So you have to see in this order. HCOA. Okay. High charge oxygen atom you can remember. High charge oxygen atom. Okay. High mean hybridization, charge mean charge, oxygen mean oxidation number, atom mean attachment, whatever atom is attached. Remember how to see this high charge oxygen atom you remember that. Either which one now put the hybridization, this is sp3. This one is what put sp2. You know to see the hybridization no put no. Hybridization done no ne. Puluanne then. Puluanne. Use what are the things we have to see for hybridization? Sigma bonds and lone pairs. Gana there. 5 bonds. sp3 and sp2. Either now which one is more electronegative? sp3 or sp2? sp2 more electronegative. Why sp2 is more electronegative? The more S character, the more electronegative. More S character, more electronegative mean? What do you mean by more S character? More S character mean less P's. Less P's are attached mean more S character. Here 3 P's are attached, here 2 P's are attached. Then more S, more electronegative. So C2 is more electronegative. So I can write C2 is more electronegative than C1. I can get the connection here. C2 is more electronegative than C1. Now we have N3, N4, N5 to connect. Now we'll see that. N3 is what, Puta? What is the hybridization? What is the hybridization of this? sp2, ne? Mea sp. Mea sp2. Then out of sp2, sp2, then n4 is the highest. N4 should be the highest, right? The more is character is on N4. Now I have to compare N3 and N5. Now N3 and N5, can you see both hybridization is same? Now see the charge. Do you have any charge? No. Here is there a charge? Yes, there is a minus charge. When minus charge is there, electronegativity will increase or decrease? Yeah. If there is a minus charge, electronegativity will increase. What is electronegativity? The ability to attract electrons. Now, if they have a minus charge on them, electron will come towards them. What will happen? Electron will repel. No, bang. Electron will go away. When there is a minus charge, electronegativity will reduce. If there is a neutral charge, electronegativity is more. Negative charge, electronegativity is more. Neutral one is more. If there is a positive charge is more than a neutral one. Can understand? Now, second thing, you have to see the charge now. In this charge, this one has less electronegativity. So N5 is less than N3, you can come to a conclusion. N5 is less than N3, finally you can get the answer. So finally C1, C2, N5, N3, N4, this will go in order. We are coming to an end of today's discussion. So thank you for all the students who participated for the session, right? And keep moving like this. So we'll come with more sessions. Okay. Next week. When is next week? Today, 22nd. Next week, 29th. We are having the session as usual. But the upcoming week after next, again 29th, maybe after that. So we are not having the A-level paper class. That day, it's a holiday. Next week, it's having the week after next. All right, then have a safe night.